past, the present, and the future. This is a bit about the past. Glimpse was, this video is about 8 years old. We'll run it again. The narrator is my little sister, Tanya. I will show you why that's important. I carry her picture because she's not with us anymore. So, Tanya was diagnosed straight into stage 4 metastatic breast cancer. And when the company Glimpse was acquired, I was working in Cupertino, grew up on the East Coast in Maryland, around the DC area. I had 2 sisters. I figure one is up there, one is down here, so maybe it's just geography. So Tanya is younger by 10 years. She was sick, so Hopkins called me in Cupertino and said, come home now. She's got about 2 weeks to live, which is a effed up sentence. You neither want to hear it, nor do you ever want to say it. So I go to Jeff, and Jeff Williams is number 2 at Apple, and he went to Tim. They took really good care of me. We bought Tanya 5.5 more months of life, but she eventually died. She died on 9/11 of 2017. So it's not a day that any of us are going to forget that. So I bring it up because Tanya was seen in her last year of life in 17 facilities because there were other new folks in medical technologies, and I've been doing this for a long time, this cancer care, and I'll tell you a little bit more in a moment. But the long story short is that because she was seen at 17 facilities, each facility thought they had her complete medical record, but if you, on average, do the math, they have 1/17. So it's a distributed information problem. Aha, now we're getting someplace. So that when you and I, through our lives, are seen, and a lot of us are traveling, Mateus and I were just talking about, he's got medical records in Rome, he's got it back home in South America. He's eventually going to have kids. They're going to be all over the place. I was just pushing because he's been married 5 years. And so I was trying to help his parents out, come back, have those kids.
Should we try it out?
Yes.
A glimpse combines the important bits of my health information from wherever I've received care into a personal health story. Simply search its listings of nearly 6,000 hospitals, pharmacies, and labs and pick the ones I've been to. I then enter my credentials once, that only I know, and Glimpse handles the rest. Automatically, in a matter of minutes, retrieving my available records and any that appear in the future. My Glimpse will always be there with the latest information when I need it. All this information is organized into categories and views, as you can see on the left, such as numbers, outliers, etc. For the first time, I know my numbers. Here I can keep an eye on things like my blood pressure, BMI, and cholesterol over the past several years from all my doctor visits. Now, if I click on Outliers, this one is my favorite. I will see things to check with my doctor that could be affecting my health. And with a single click, you can see its history. If I'm looking for something specific, like my LDL results, I can just search for it. I can also add things that might be missing from my Glimpse, like my chemo treatment, for example, and keep track of how I'm feeling before, during, and after my treatment. As you can see, I had some pretty low days around the time of my stage 4 diagnosis. But this is my favorite part. I can securely share my entire Glimpse with anyone I choose, like my doctor, for example, just by entering their name and email address. And soon I'll be able to help others by donating a copy of my Glimpse to research, aiding in the discovery of cures and treatments.
How do we aggregate it in one place? Within the threshold of something called HIPAA, you folks have worked in the industry, any place, so there's this somewhat draconian box that folks need to live in. HIPAA says you can't do this, you can't do this, you can't do this. The thing is that the patient is outside of HIPAA. The patient can do whatever what they want. So if Tanya wanted to post her video to, some billboard or some website named SaveMyLife.com, she could post everything about her. No individual institution can do that. And even if they could, they don't want to, because the control of Tanya's information is control of a really important asset. So this notion of interoperability that we have, either heard or will be hearing about, it has a disincentive for one institution to share with another institution, because a late-stage cancer patient is actually, let's be crass, that's the $1 million patient. You're not going to just move it. So it's as silly as asking Target to share their CRM data with Walmart. When you think about it that way, that's never going to happen. So let's fast forward. That's the history. Where we are today is a third of you folks in the room are working for this company that I'm part of. And if Pawan will raise his hand, he is a colleague of mine at this 4-month startup. And we are trying to pull together, as Dr. Evans here, I'm just going to call you Dr. Evans because I loved your presentation. You could just translate everything from the MediaWiki Plus to MediaWiki Plus Plus for healthcare. It's distributed. It has rules, it has processes, you have care guidelines, you want to make sure that everyone's getting standard of care. I mean, the analogs are amazing. So we are working now on a project that has 3 long poles in the tent. One is we need to build an infrastructure where hospitals, clinics, radiology facilities, both in the US and internationally, can deploy something behind the firewall. Okay, let's just call it MediaWiki. Then we need to upgrade it to have data structures and graphs and semantics that are healthcare specific. Meaning, like, what do we know about medications that is not PHI, not personal health information unique to a person, but just we know something about acetaminophen. And we know it's called Tylenol, and 200 milligram, and it comes in caplets. So there's a number of attributes to every node. So the categories of the information that we need to put into the semantic graph are like meds, labs, diagnosis, procedures. And if you go down those 4, there's about 17 total. And if you go across meds, it turns out that the top 10 pieces of information are the critical ones that everybody wants. Who was the prescriber? So you have a person. What was the location? What was the date? Okay, now, what was the name? What is the generic? What is the unit, the milligram, the route of administration, oral, whatever. So if you look at the 17 times 10, turns out you've got 170 attributes that make up 80-20 of healthcare. But a lot of them are duplicated because a date is a date is a date. So when you bring it all down, its number is 47. So 47 attributes. If we could semantically load them into a graph that is behind the firewall of Hopkins, where she was seen, and that's where she passed. But she was seen at Sutter and Stanford. You could load it all in, have these thousands of hospitals and 100,000 clinics in the US, and now international, share that information, and a single copy could be shared on some master server, and that's Tanya's selfie. Take a picture, it's not exactly you because the Instagram filter makes it look different. Well, this is the medical version of you. It's your digital twin. And in order for language models and knowledge graphs to operate, because they are algorithms, they embody knowledge from clinical medicine. but they need to operate on something. So a digital something can't operate, it's got bits and bytes, it can't operate on atoms and molecules. So we need to build a digital twin. I'm not sure that's the exact logo, but I liked it, it was cute. The company's only 4 months old, we're in stealth, so it is what it is. So the current project is this. 3 long poles in the tent. I've just been describing how MediaWiki, the medical version of MediaWiki, could be groundbreaking. There's another 2 parts to it. One is how do you build the corpus? How do you build this knowledge graph? That's one. And then how the heck do you get the information in the first place? Because remember that HIPAA thing? That's like a door. But I also said that the patient is outside of HIPAA. So why now? Why is this possible to solve now? Really 2 things have happened in the world in the last 18 months. One is someone taught a machine how to talk human language. So the API has changed from Python and REST to human language. Well, that's huge because the bulk of Tanya's data was not in the database, the SQL tables. It was in documents. One is a radiology report. So if you're really ill, a lot of radiology, imaging is just growing leaps and bounds, and the byproduct, the exhaust of that, is a document, usually 2 pages, and there's this juicy paragraph called the findings paragraph. And it says 6 metastases were found in the right lobe of the liver at the size and location. It's exactly what my sister died from. Hepatic complications. No one dies from breast cancer. It's a non-functional organ. But when you're metastatic, lungs, bone, liver. So now we have a machine that prefers to ingest natural language and make sense of it. Of course, some of that sense is garbage because it will hallucinate. We'll get to that in a second. But look, that happened. So if we agree that in the 80-20, usually 90-10, the bulk of the really interesting information that everybody wants is not in the database because that's billing information. It's charge capture and order entry. It is Salesforce.com, like any other name, to run a hospital. They have incredible power, these medical records companies. I don't know why, because when I walk into a facility, I don't go, do you run SAP or Salesforce.com? I could give a crap. But that's not the case in the hospital environment. These people have incredible power. I'd like to shift the power base. So they have these documents, discharge summaries, pathology reports, imaging reports. That's where the information is. So something happened, and now we can just shove documents into there. I know because I've taken Tanya's, literally her fax pages, and sent them in. And what comes back is an incredible amount of understanding. It's a widget of understanding that I can ask, what is this patient suffering from? And the question was, can you give me the answer in 5 words or less? And the answer was metastatic breast cancer. That's GPT-4, that's untrained. We're about to train it and build a semantic graph, a fact table, not a language model. That's a means to an end. A language model is an API, that's how we talk to it. It models language, but it will, I don't know why I keep looking at Rich, because he's not, I'm your anchor. Yaron introduced us a couple of years ago. It was April 6th, 2022, and we were just, he forgot, I knew, but I remember. So that's the second piece. The first one, one of them is MediaWiki is the infrastructure. I'm just convinced. Number 2 is we've taught a machine to understand this juicy information. And number 3 is we need to build a knowledge graph, not a language model. Facts, guesses. I'm just going to leave it that way. So we are on a project currently to take some of the understanding that this company has about clinical informatics and help build the medical version of MediaWiki. That's plus, I don't know exactly what that's going to entail, but one of those pieces is Ike and a number of you have helped. Ryan is here someplace. Anyway, yes. Bad to say. Look, this is your health information. We can't just have people willy-nilly just editing it. So we needed to build some sort of a veneer that has security and privacy. Gosh, that should be just a part of MediaWiki eventually, or at least a part of the medical version of Plus, MediaWiki Plus. So that's what's going on. The ultimate goal is this. I'm gonna run something if I can find it.
Hello, today I would like to introduce you to a project that I am most excited about and is being built by my dear brother Anil. Selfie is swiftly advancing a billion-dollar revolution in healthcare.
Look, going forward, I think it's possible to have an avatar. Of course it is. We got Alexa, we got Siri, we got other avatars. Someone, maybe us in this room, is going to create a voice interface to the knowledge base, but in the middle is your digital twin. So everything you're going to ask of all of this, the Google of healthcare, the knowledge base of healthcare is going to be filtered through your digital twin. So you're not just going to get random links. You're going to go, hey, Tanya, tell me something about myself. And she's going to go, well, you had stage 4, but now you're in remission. Tanya, what was that? This is real. I'm standing in front of the pharmacist at CVS, and the elderly gentleman with the bag, he's taking out his medications, he's going, I think I need one of these. So he calls his wife, hey, what was that blood pressure medicine? Well, now he's going to go, hey, Tanya, what's that blood pressure medicine I was taking? And up on the screen is going to come up, and he's going to go like this to the pharmacist. And it's got a QR code, it's going to, all of that. So if you close your eyes, and if you think about that possible future, all the knowledge brought together from distributed under the auspices of the patient, which is the only entity on planet Earth. I don't care whether you call it GDPR or HIPAA or whatever they call it in China or sub-Saharan Africa. The patient usually has the ability to aggregate a copy of their records. So that scales. We know this framework. Thank you, sir, in the back. We know this framework scales because it's the largest server farm in the world. I'm super excited that we have the tech. Regulatory overheads are sort of sidestepped. There's something that came out about a year ago called the 21st Century Cures Act. I like that name. Effectively, it says the people who have your medical information that have sort of kept it behind doors, there are no doors that you can't knock on anymore and say, give me my data. So when you have a regulatory solution and a technical solution like OpenAI, I really think that kind of stuff that I've been trying to work on for about 40 years is finally about to happen. My background's in biomedical engineering. I love this stuff. I've been doing startups for a while. For the last 40 years, one failed. You learn a lot. One, we took public on the NASDAQ. 4 had exits for WebMD and Citrix. Apple acquired one. But I always feel like that's a warm-up act for what we're about to pull off here. So I am super thrilled to share this idea with you. I think I'll stop there. And if there's some questions, or I just want to. We have about 2 minutes. Sir.
So not a question as much as a thought that I had while I was listening. One of the things that we're going through is digital transformation. And when you were talking about the patient being outside of HIPAA, and their information sort of being locked.
Yeah.
Paywalled or, organizationally.
I mean, you're a patient.
Yeah.
It's hard. Yeah.
The term that I've discovered recently is digital sovereignty.
Ooh.
And I found that that's a very, that digital transformation and digital sovereignty have to be, go together. And the patient has sovereignty over their data.
Worldwide.
Yeah.
We have some technologies in the US, we think they're really good. We have some APIs, but when you add up all the people that are affected by that, okay, maybe there's 500 million people on planet Earth. What about the other 7.5 or 8 billion? We don't have these medical record systems in India. They just don't exist. So the APIs don't exist, which means the apps won't work. Something like this will scale. When you talk about sovereignty, I'm thinking about Web 3, because Web 1 was read, Web 2 was write, post, and Web 3 is own. That's one man's opinion. Own means the infrastructure for blockchain transactions. So you have the sovereignty because your record that is in one place could be considered a token. And it's non-fungible because you're unique. Rich is more unique than others.
I'm gonna crawl under the
No, I was very impressed when you told me about the semantic work you were doing, and now I'm gonna bug you because a lot of work that you have figured out is translatable. So thank you for that. But yes, the patient now gets to own, in other words, an NFT, then you have smart contracts that said, the patient says, I would like to be part of that clinical trial, and you, Pfizer, may pay me $10,000. Gonna make it up. It's a low number for clinical trials. But you're gonna get to use it for NCT, that is the number of the trial, NCT 1, 2, 3, 4, 5. And you only get to use it for that, and it's built into the contract, and now I don't have to worry about someone de-identifying my data and doing things with it, because there's a record of our agreement. I think sovereignty sort of is the umbrella term that covers that kind of capability. So somebody in the room will need to work with us to say, I would like to do the blockchain extension or the plugin that then we can add to the medical version of MediaWiki.
There has been work, I don't recall exactly who, but in one of the MediaWiki stakeholders meetings, someone gave a presentation on including blockchain into the edit history of the articles, so that.
That was Hello, right?
Yeah, I think it was. Yeah, and I was blown away by that, and I'm just like, that's the future. And once MediaWiki has that blockchain in the edit history, I think that's a evolutionary milestone.
Why that's so important? Because physicians will not trust information that just comes from the patient unless it comes from another attested covered entity under HIPAA. So one physician has the obligation to tell the other physician the good stuff. But when we move from acute care to chronic care, most of that good stuff happens outside the medical environment. It's the digital exhaust and the other 360 days when you're not in the hospital. So how does a patient attest that this really was me, it's not fished, it's not spoofed? You write a little record and you say, I, the patient, to attest to everything. It's written, so it is a record. Your journey is events of a record. So that makes sense. Pavan, let's make that a feature. He goes, yeah, sure.
We just borrow.
Huh?
We don't have to invent, we just borrow.
We just borrow it. Yeah, that's the beauty.
Open source.
In the YouTube stream, Bernhard, who's going to be speaking a little bit later, says this is a big thing in Europe. The Data Act defines frameworks for voluntary donations of private data, for example, for research purposes.
Yeah.
And that the blockchain talk is by Marcus Blazer of Palo Alto.
Thank you to
Bernhard Kubina.
Bernard. Thank you. I'll finish with one more thing. How the heck do you get all this data for the patients? You can't just go knocking on the door of all the hospitals, and you can't have 300 million patients suddenly find out. It turns out that for the last 30 years, there's been this underground network called Health Information Exchanges. It was a private subway system only for hospitals and doctors. They transferred records, documents between each other. Obviously, these are tested because it's going from one doctor to another. The people who built the exchange networks, wrote the code, built the servers, the protocols, all of them happen to work for this company. We've been working with these exchanges, consider them like cell towers that connect all the phones, 300 million phones. Let's say there were 75, I'll finish in a second. Let's say there were 75 cell towers that moved the information. That's about how many exchanges there are. We have about 21 that are clients of ours. That means behind the firewall, those 21 hold currently 128 million patient lives of information. I can't see it because I'm not allowed to, but I don't want to. So what we're going to do is we're going to put our machine learning code behind the firewall, train it, then take the model out. No PHI ever, no health information ever gets exposed, but we get to use our partners. Why would they do it? Because when you've got all this information in a health graph or a semantic, I'm going to mix these, and you put the clinical trials, which are documents, and we know we can process them. Now you've got supply and demand in this graph, and you can run trials matches. Our test says that we can onboard a patient, go to a website, selfie.com, onboard the patient. We use Clear to identify, that's another 90 seconds. You don't have to tell us where your records are, you just say consent. We scour the exchange network, find where your documents are in the multiple places, bring them in, put them through our chipper shredder, produce data, refine it according to terminologies and ontologies, because they're standards, like in medications. Then we put it into the graph. Every night we run I'm going to call it a cron job. We just run a match between the patient and the trial. We believe that in real time, we can do this in under 10 minutes. From how do you do to you've been matched. That's the future. So thanks for helping. I'm going to step out and
Yep.
we will do some more.
Thank you.